Scientific Sue here, and welcome to UCD's virtual festival. Well, it's been an exciting couple of days, and so this is day 3, and it's the third part of my really rubbish science show. So day 1, we looked at basically what litter is, and we then looked at dissolving and floating and sinking. We then yesterday looked at plastics and polymers, and today I'm going to be looking at the science behind graffiti. Now, a lot of people say graffiti can't be litter, but it is. It's paints in the environment where people don't want them to be. And there's a huge amount of science. So what I want us to do, first of all, is for us to make our own set of paints. And we're going to use vegetables to do this. And the first vegetable we're going to use is a red cabbage. Now, what I've done is I have dried my cabbage. Now, you don't have to do this at the moment because we have these purple cabbages in the shops at the moment, but I want to show you this. Okay, so whenever we have kind of packaging, we can use our bottles there to be able to kind of store our foods. So what I've done is I've put 3 teaspoonfuls of my cabbage powder into here, and to that I'm going to add some water, some hot water. So we have to be very careful here. So it's mummies and daddies that are going to do this. And again, we get this lovely purple juice. So why do we call this a red cabbage when we get this purple juice? Now, what I'm going to do is I'm going to put this into a bottle. So at the moment, the red cabbage is starting to absorb a lot of the liquid. So it started off as a powder, but over time those pieces are going to rehydrate, and we don't really want to have kind of cabbage bits in our experiment. So I'm going to sieve this so that we just end up with the dye. There we go. And if you don't use all of this at once, it can go into the freezer, and then you can use it at a later date. And thousands of years ago, people were using pigments from plants for them to be able to dye their clothes. And a purple dye was supposed to be very special and regal. So it's only the emperors in Rome were allowed, or the royal people were allowed to wear purple in their clothing. Right, so what we've got now then is we've got a dye. And I'm just going to put those down there and take that out of the way. And so what we need to do now is we need to set out some cups. Perfect. So there's my cups. And now for me to be able to make the colours of the rainbow, I'm going to need another colour. And I'm going to get that from another plant. It's the turmeric, the root of the turmeric. So what we're going to have to do now is we're just going to have to stop for a minute while I prepare the turmeric and get another colour, and then we can mix them. To make the yellow colour, I'm going to use this root veg called turmeric, and we can see here it's a lovely yellow orangey colour, but when we boil this, it's going to be more of the yellow colour. So I'm just going to chop all of this in very thin slices. There we are. And then we're going to add this to a pot. So I'm going to add it to one that I had chopped up earlier. We're going to put some water into it so it just covers the roots, and we're going to boil for about 3 minutes. Right, so I have just removed it from the stove. So we've got a lovely kind of deep colour there, and I'm just going to sieve this. Look at that lovely deep, it's kind of like an orangey yellow at the moment, isn't it? There we go, that's all in. Now you have to be very careful when we're using this because it did overflow on the stove, and when I went to clean it down, my lovely cloth, look, is not white anymore. It's got lots of yellow on. So that's the colour yellow that we're going to get from this natural dye. That wasn't very difficult, was it? So we now have the yellow from our turmeric root, and we've got the purple liquid from our cabbage. Two other chemicals that we're going to need. It's going to be vinegar, it's our acid, and the opposite to an acid is a base, and I've got some baking soda, some bicarbonate of soda. So first of all, let's just kind of put some of my juice into this cup here. There we go. It's a lovely purple colour. But whenever we have this cabbage, if we pickle it in vinegar, it changes colour. And it goes from purple to red. Isn't that lovely? So we've got a red colour there. So we want some yellow. So then I'm going to put that yellow there too. There we go. And if I mix red and yellow, what colour am I going to get? Should we find out? So we're going to put a little bit of yellow in here. Okay, there we go. And I'm going to put some of my red in there. Then I get orange. So now I've got orange, and make that a little bit more orangey. I've got red, orange, yellow. Now I want to make green. So for me to make green, I'm going to have yellow and blue. So I'm going back to my cabbage juice here. So the cabbage juice is going in. And what's amazing about this cabbage juice is when it's in a weak base, it's going to give me the colour blue. So I'm just putting a small amount of the powder in, just a little bit in, and we're going to give that a stir. And I've now got a blue colour. There we go. So what I'm going to do now is I'm going to put a little bit of the blue into this cup, and I'm going to put a little bit of the yellow to mix it in, and we end up then with green. So we've got yellow, green and blue there. We've got our orange and we've got our red. So the last two colours are going to be our indigo and violet. So we're going to use our purple there as our violet. And indigo is a mixture of the blue and the violet. So when we look at our rainbow, our orange is the mixture of the red and yellow. We're going to have the green is the mixture of the blue and the yellow. And our indigo is going to be a mixture of the blue and the violet. And there, it's a bit too blue there. So let's make that a little bit more pronounced there. Fantastic. So we now have got the 7 colours of the rainbow. And each of these here will allow us to dye clothes in those colours. So there's a whole load of things for you to explore on your own to find out how we can do those. But if I kind of reduced the amount of water that's in here, then these dyes will get a darker colour and a darker colour, and we could then maybe use them to paint. Now, so I'm going to keep my cabbage juice, put my lid on. That's going to go in the fridge for me to play with later. And now I've got these wonderful colours. What I did was I put some spaghetti, cooked it for about 3 minutes, put some spaghetti in these colours, and I've made a piece of art. Do you want to see it? It's quite amazing. I think it's quite amazing. So I've got it here. Hang on a minute. Look at that. Now, for me to do this, it took me hours. Hours and hours. And you can imagine then, if I've made a piece of artwork like this, and I've displayed it, say, on the side of my building, so that everybody knows what my business is, and then someone comes along and sprays paint all over it, am I going to be happy? No. And there's lots of businesses out there that are not happy with graffiti on their walls. Red cabbage is pretty amazing, isn't it? Yes. So I've kind of filled all the cups up now, so they're all equal levels. Red, orange, yellow, green, blue, indigo, violet. The only colour we can't make with the red cabbage is yellow. So we get that from our turmeric. Now, there's lots of chemistry in this cabbage because you noticed when I put it into an acid, I got the red colour, and then when it went into an alkali, I got blue. And in fact, in the alkalis, as I put different strengths of alkalis in, I can get into brilliant greens and bright yellows as well. But that bright yellow is using sodium hydroxide. I don't want to do that because that's quite nasty. Might be using that in a minute though, but let's see. So what we've got then is we've got this chemical that changes colour depending on whether it's acidic or alkaline. Now, when I talked about my baking soda, I said it was a base. That's because it's a solid. When we put it into a solvent, say water, and it dissolves, then it becomes an alkaline solution. But acid, whether it's a solid, a liquid, it doesn't really matter, it is going to be an acid. So I've got an acid here. I've got citric acid here. And this is what we get on kind of crazy sweets. I've got them here actually. Let me just kind of reach over. I don't know whether any of you have tried these. You tried toxic waste. I bet we've got loads of young ones in there. I'm going, yeah, I love it. Don't try it if you've never tried it. You put them in your mouth, it turns your face inside out. They are very, very, very sour. So any of the acids that are safe for us to eat or drink are very, very sour. But that sourness can be good whenever we're cooking because we might want that kind of that kind of sourness in the food. So I got my citric acid and I've got another base here. So this one is a washing soda. Now, what I've got here is my cabbage juice, okay? And I'm going to put some of the washing soda into the cabbage juice. There we go. So it's going in and it's changing colour and it's going from purple to quite a dark green. Isn't that amazing? Lovely purple to a dark green. Now what I'm going to do is I'm going to add some of this into these two beakers. So it looks as though that we've just got water, but when I put the washing soda into this one, it's like magic, isn't it? I get a wonderful pinky colour. And when I put it into this one here, I get a blue colour. Now, this science is in some amazing pens. I'm going to introduce you to them next. Okay, so this is what I went to find. Got these wonderful pens. They're called Friction. Not spelt the same way that we spell friction. It's got an X in it and we've got lots of colours. So I've got black, green, red, yellow, pink and blue. Now a lot of people, whenever they are using graffiti, they sign their name. They say they're tagging their picture. Okay, so there's my name. So I've written that in blue. And in fact, sometimes whenever they tag, they also do kind of like weird things like that. I don't know what that weird thing is. But on the end here is a rubber. And whenever we make a mistake with pencils, we can kind of use that to rub something out. So what I want you all to do before I kind of try to remove this, put your hands together and start to rub them. And go faster and faster and faster and faster and faster. Can you feel that heat energy? So when we have two surfaces, solid surfaces in contact, and they rub over each other, we generate some energy, some heat energy. And the more rough the surface is, the more friction force we get and more heat we can generate. So whenever I use the rubber on here, okay, and I just kind of move it really fast, I can make my name disappear. That was hard work, but it's gone. It's gone. Inside all of these liquids, there is a chemical, and I don't know what it looks like, so I'm going to pretend it looks like this. Part of that chemical is an acid, and it's attached to the chemical with a bond. And it's quite a strong bond, But if we put heat energy there, it can leave. And once that acid then goes into the inks, well, let's see. So what I'm going to do is I'm going to put some of my citric acid into here, and I'm going to put some of my citric acid into there. Can you see it? As it starts to dissolve, these liquids go clear, invisible, they disappear. So with this one here, the chemicals that I'm using, I have to put that acid in to get that reaction. In these ones here, in the pens, they already have that acid attached to a molecule. But to get it to become released, you have to rub it and heat it. And what's really cool about these pens is you can write a message, and you can use your rubber to remove the message, and then when you put it back into the fridge, that reaction is reversed, and the acid then reconnects with the molecule, and then we see the colour again. Isn't that amazing? So what I had here were two kind of indicators. So whenever we have chemicals which change colour and let me know if I've got an acid or an alkali or some chemical reaction, we call them indicators. So if I'm riding down the road in my van and I want to tell people I'm going left or right, what do I switch on? Exactly, my indicators. We use exactly the same language in science as we do in everyday life. So now, if I put some of the washing soda back into here, what do you think would happen? So here's my washing soda. There it is there. And let's see if we can reverse that reaction. So put some washing soda in there, put some washing soda in there, and we reverse it. Now, I've still got a lot of acid in there, so as soon as it kind of goes in and forms the colour, the acid is going to work on it and it's then going to become invisible again. In fact, this gives me an idea. Why don't we try to make some disappearing ink? So that means I can have all the fun of being a graffiti artist, but then as soon as I go away, carbon dioxide in the air, that's acidic. It will work on my painting and it will disappear again. Do you think that's possible? Let's do another experiment. So I'm thinking, can we make some disappearing ink? Now, to do this, I'm going to need some thymolthylene. So I've got some here. I've measured out 0.1 gram of thymolthylene with my very sensitive scales. I'm going to need 14 millilitres of 70% ethyl alcohol, rubbing alcohol. So that's there, fantastic. And I'm going to add those in together. So this powder won't dissolve in water, but it will dissolve in an alcohol. So the alcohol is the solute here. Now, once I've kind of got that stirred up, I am then going to add it to 90 millilitres of water. Now, don't worry if you don't have measuring cylinders like this at home. Some of you might be lucky enough to have baby's bottles, but we can kind of use the baby's bottles. They're much cheaper to be able to measure out our volumes. So when I put this in here, it will go a nice kind of cloudy colour. Brilliant. Then to this, I have to add a very strong solution of sodium hydroxide. And this is something that we would have, some of you might have at home, caustic soda, to help clear drains. It is a very nasty material. And we're going to need 20 drops. So I'm going to step back, and then let's count 20 drops.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20.
20 drops has gone in there. And we have now made some ink. And it's very dark blue ink. And I made some earlier. I'll Okay, so I've got my spray here, and I'm going to just use my funnel to top that up for us to use later. There we go. Now remember, for this to disappear, I am going to need an acid. And in the atmosphere, we've got lots of carbon dioxide gas, and carbon dioxide gas is acidic. Not a strong acid, it's a weak acid. Now, put that there. Do you think my screen cost a lot of money? It did. Would I be happy if somebody kind of put graffiti on it? I don't think I would. Now, put the little lab here. Ready? Ah! It's all over my screen! How am I going to get rid of this? Can you imagine the reaction when somebody squirts you with this disappearing ink? So it's there. Let's see how long it takes for that to disappear. While we're doing that, let's do another experiment. Okay, so got the disaster behind me, but I did mention it's not just going to be acids that can release this chemical. So what I've got here is I've got a message. It's been tagged as well, so I put a tag there. And this paint is super special. So the paint is on this cup as well. A bit thirsty, so what I'm going to do is I'm going to pour myself a drink of water, and so I'm going to put it in there, and let's see what happens. So in it goes. You can see hopefully some of the steam coming up because this is warm water. Uh-oh, it's got all over my poster. So what we've got here then is like magic. Can you see this? See this? My logo is coming through. And these paints are called thermochromatic paints. And you've got to remember, this show is all about litter. So we're just talking about graffiti at the moment. And oh, not only do we have Science Life, we've got me as well, Scientific Sue. And these thermochromatic paints are amazing. Wouldn't it be fantastic if all the graffiti could just be removed like this? So what I've got here is I've got my hairdryer. So I was saying about these friction pens, you actually don't have to use all of that elbow grease with those pens, because I actually went to the company that puts the ink in the friction pens. So, and I bought the black colour because it took me ages just to kind of keep drawing. Now let's have a look and see what we've got here. Get rid of all the water that I put there. So I'm going to put this on hot. Are we ready? Ready for this? The only cure for litter is you and me and everybody. You and me and everybody. So I've kind of got that one there. That's just on paper. If I put this back in the fridge, it will go back to being black immediately. But it just kind of has to cool down here as well. So let's do that again. But this time, I want you all to get ready with your pointing fingers. And when we kind of get to that last punchline, I want you to start pointing to everyone in the house, and yourselves. Because remember, whenever we are putting food or paper or plastic on the streets, we have a choice. We don't have to do that. We can just put it in our pocket and take it home with us. If we walk past the litter, we could pick it up and put it in the bin. And if everybody did that, then there would be no litter. So get ready with your pointing fingers ready. Here we go. So what is the cure for litter? This is it. The only cure for litter is you and me and everybody else in the house. There we go. It helps if you have it on the hot setting, doesn't it? Now, so let's Let's have a look behind me. Ah, da, 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 da. It has gone. So I thought I would just finish today with something a little bit crazy, because of those of you that know me, I'm a little bit crazy. Now, let me have a little sip of this water. I was a little bit thirsty. So we're going to put that there. We can buy these in the shops. It's an acid-base reaction that allows us to get from the colour to invisible. So we're using chemicals which change colour depending on whether it's an acid or an alkali. So we call those chemicals indicators. And remember, at the beginning, I used the cabbage juice to kind of get me a whole range of colours here. And but I couldn't use the cabbage juice to get the yellow. What did I have to use for the yellow? Yeah, turmeric. It's supposed to be very healthy for us. And then using those colours, I was able to kind of colour some spaghetti and make myself, knocking everything over, a rainbow. What could you make? Now, it doesn't have to be spaghetti, because remember earlier, got some of that turmeric on the cloth, so we can kind of put different cloths in, maybe tie-dye a t-shirt. Now, you may not have seen this here. Here's my lab coat. So I thought, well, if we're going to be silly, let's be silly completely. So I'm Scientific Sue, and you have just seen my really rubbish science show. We're at the UCD Virtual Festival, and what we're going to do is we're going to cover my coat in graffiti. Look at that. Now, it's there. This one took too long to disappear because the acid that's here is only a little bit of carbon dioxide in the atmosphere, so it takes a long time for those little molecules to find its way onto the sheet. But I've got a fire extinguisher here, which is filled with carbon dioxide. Now, unfortunately, you can't do this at home. I have a company around the corner that refills this, because as soon as these have been used, they cannot be used again. Okay. So never play with a fire extinguisher, because it's there to put out a fire. But what I want to do is to demonstrate how we can kind of get rid of this graffiti really quickly. Are we ready? 3, 2, 1. Uh-oh! Did you see that fall over? We had a huge push. Yeah, you see, unfortunately, let's pull that up again. It's gone. But whenever we're cleaning litter off of walls, we have to blast it. And when we blast it, we damage the brickwork underneath. We have to use lasers, and that costs a huge amount of money. Removing graffiti costs a phenomenal amount of money. Should we do that again? Yeah, I think so. So this is my last demo. We're going to put the graffiti on there again, and let's see this blast. So, happy festivaling, everybody! 3, 2, 1!